Hello. So, I'll show you how to do the confidence interval between two proportions. Here, the population proportion. So in the notes, it's right here. Confidence interval for the difference between two proportions. So if you look here, it's p hat 1, p hat 2, minus p hat 2, and p hat is like the sample proportion instead of the population proportion, and p1 minus p2 here in the middle is the population proportion, which is what we're trying to estimate with this interval. So you need the z-value for your confidence interval like a normal interval. And for this homework assignment, he said to assume 95% confidence. So your z-value is going to be 1.96. Then p hat 1, q hat 1, and then q is just 1 minus p. So they'll give you, p hat 1 is a proportion that you'll find within the article. So here, I'll show you an example. My article here is the Fox News poll, Trump narrows Clinton's lead. So, here, I don't know where it is. So here it shows that Clinton has a 41%. That's like the proportion. So that is the p hat. And that's p hat 1, which I have here, is 0.41. And then x1 is another thing you need for the confidence interval, which is just like the proportion out of the n, which is the n is the sample size. So you go down farther, and at the bottom of the thing it says this poll is based on 1,011 randomly chose voters, so that's n1. And then margin of error is 3, plus or minus 3, which we'll do, you probably know how to do that, but I'll just go over that later. But so this is the x1. And then to get, this is n1, sorry. Then to get x1, I just took the proportion times this. So p hat 1 times n1. Sometimes they give it to you. For example, in my other one, which is the YouGov one, which shows that Hillary Clinton has a 42%, it gave the number of people, which was 546, and p hat 1 was 0.42. And N2, these are all 2s, not 1s, 2s was 1,300 people. So to do the confidence interval, you need p hat 1 minus p hat 2. In this case, I just flipped them, so they would be, so it would be positive. So it's 0.42 minus 0.41, since Hillary Clinton's lead was 0.42 and then 0.41 in the other one. And then plus or minus, and then 1.96, which was the z alpha over 2. So it's like the z value, which is 0.05 over 2. So it's the z value of 0.025. And then you take p hat 1 times q hat 1. Q hat 1 is just 1 minus p hat 1, which in this case is 0.41. So it's 0.59 over the sample size. And then plus p hat 2 times q hat 2, which I got the same way as I did here, just a 2 instead, 0.42. And then over the sample size again, and then the square root of that. So then I just did that, and I ended up getting 0.01 plus or minus 0.0405. And then this is my confidence interval. Basically, this means that we aren't confident that there's a difference between the populations because there's a negative on the other side. So somewhere in there, there's a 0, which means that if there's 0 difference, we're not confident that there's a difference between the population proportions. So basically, we're saying that in both polls, Hillary Clinton has like a pretty similar, like the same lead. So I just found 2 different websites, and I just decided to do the election because it was the easiest one to find survey data. And then for the margin of error, you have your E, which is the margin of error, which is, they gave it to you in the first one that I used. I used the Fox research one again, and it's 3 percentage points, so that's 0.03. The alpha is 0.05, just like assuming 0.05. And then p hat and q hat are both 0.5. He said in lecture that we just assume that's 0.5 because it gives us the largest, like, I don't even remember what he said, but he said something about use 0.5 whenever you're doing these because it'll give you the most accurate answer. So the formula is, like, I just got the sample size that we would need. So hypothetically, you need the sample size of 1067 to get the most correct answer. And then you have to do, like, to verify the margin of error, you have the margin of error they gave you equals, and then the things that you're assuming. So the z-value is this for a 95% confidence interval. You're assuming that p hat and q hat are this, and then you're assuming that, then this is the actual sample size. So you're checking basically what they did. And so this 0.03 is what they said, and 0.031 is what I calculated.